Yeah, hi students. I am Dr. Badrinath. In this video, we will see the bioassay of insulin. Totally, there is a 5 methods are there. Keep in your mind. 1, 2, 3, 4, 5. 5 methods are there totally. In that, mainly 2 methods we are using. One is a mouse method. See mouse how nicely it is going like this. Towards the rabbit. And another one is a rabbit method. So these 2 methods are important among the 5. Insulin, we know very well. It very good for the diabetic, okay, especially type 1 only they are using for type 1 only, insulin dependent diabetes. This is a syllabus unit 5, okay, of your as per your university, pharmacology for nursing, B.Pharmacy, MBBS for all them, okay. And here you can see bioassay. Here this is a point highlighted with the reading, bioassay of insulin. That's we are going to be discuss today. Yeah, key terms what you have to keep in your mind in the bioassay. Whenever you are doing, always you are comparing the test substance, that is a test insulin, with the standard insulin. Compulsory you have to compare, then only you can do the both potency, how much dose, how much you give, what is the result came, calculation. According to that you are calculating what is the potency of insulin you have prepared in your lab. Okay, like that we are doing a biological assay. So compulsory there must be international standard insulin preparation and test insulin what you have prepared. Okay, and rabbit method you can use, mouse method you can use, any one method is enough. Don't use all 5 methods. In the exam they might ask all 5 exam, but whenever you are doing a real assay in the lab, you can use only one method. Okay, that's more than enough for that. Okay, yeah, principle of the rabbit method. In the rabbit method, what we will do, insulin natural character we are going to be study here. So we know that insulin reduces the blood sugar level, that we know very well. Same property only here also we are testing. So to this rabbit, see how it is blinking the eyes and ears. Rabbit having a high blood sugar, we are giving a insulin injection. See here, insulin injection we are giving to a rabbit. That rabbit is having a high blood sugar level. So what happened when you give an insulin? Reduce the blood sugar level. See how the blood sugar level, see white color dots. See how it is reduced. Okay, that property we are going to be standard also we will do, test also we will do. For standard, how much blood sugar level reduced, for test how much blood sugar level is reduced. Both data you are comparing. With the help of that you can calculate what is the percentage of insulin present in your test preparation. This is a rabbit method basic principle. Mouse method principle. Here what we are doing is we are not finding the character of the insulin here. Original character of insulin we are not studying. That is a hypoglycemic level. Only we are studying in the rabbit method. In the mouse method, see, keep in your mind, when you give an insulin injection to a mouse, it undergoes the convulsions. Convulsions will be attacked to the rat, to the mice, whatever it may be, rat or mice, whatever it may be. Okay, mice, mouse, rabbit, rat. Okay, not rabbit, not rabbit. So healthy mouse, see here, healthy mouse, you are giving this mouse, we are giving an insulin injection. So that what happened, convulsions will come like this, jerks, body jerks, hands, forelegs, hind legs, backside, and also tail, all jerks will come. That property we are going to be studying. For test preparation, for standard preparations, how much convulsions are produced for test, how much convulsions are produced in the standard, and same we are comparing with the calculation. That point you have to keep in your mind strongly. 2 basic point you have to keep in your mind. Yeah. Now I have told now standard preparation. This is the standard preparation. International standard, you can see here. International standard. Not small, not national or nothing, but it is, okay, it is a standard. It is a pure. See here how dry crystalline insulin. See here, this is a crystals. How the crystals are very nicely, that much of purity will be there. that purity, dryness, dried crystals, pure crystals. Okay, with that we are preparing the standard insulin that they will prepare and sell. You need not to be prepared in your laboratory. Standard preparations always you have to purchase from the international bodies or national bodies also. They can maintain the international standard. You can just apply them and you get it international standard. Don't prepare standard preparation in your laboratory. What you have prepared in your laboratory, it is a test preparation only. 1 unit contains the 1 unit of this. We know that insulin we are measuring in the units, 2 units, 3 units, 4 units, 20 units, like that. They are taking an injection, insulin injection. These units, 1 unit of insulin contains the 0.04082 mg, not grams. 1 unit, keep in your mind, 1 unit is equal to 0.040 you can keep in your mind, 40 80. If you double, you will get 80. Like that you can remember, 40 80. Since you doubled, you can add 2 here, like that, or 4 into 2 8. See the pointer, like that, mg of insulin, like that you can remember, very easy, very easy. This unit is specified by, not by me, it is specified by the Ministry of Health, Government of India. It is a equivalent to international unit. So international standard only we are preparing. This is a test preparation. What you have prepared in your laboratory, you have isolated from the animal insulin you have prepared. Okay. And we are labeling as a local insulin. Now we are comparing what is the potency of this insulin, how much it is there. That we are comparing, either it is a 90% insulin, 95%, 100%. That we are comparing with the international standard in the animal by using the any suitable method. And now we will prepare the standard solution and test solution. See here, preparation of the standard solution here. Here, preparation of the test sample. Here, standard. See, you have purchased the standard sample from the international bodies. Okay. Now, solution, you prepared the solution. From that, accurately weigh 20 units of insulin. 20 units. Each unit I have already told 0.04082 mg. 20 units you have to weigh accurately. Okay. And dissolve in a normal saline. Don't use water. Normal saline you have to prepare, because we are going to give to the assay, all bioassay dilutions you have to made with normal saline only. Don't use water, because if you are using normal saline, then the animal tissue will be in the living condition, because we are going to give this preparation to the animals. Acidify, then make it a slightly acidic, just like a pH 2.5 with the help of HCl. Not, don't use any other things, only HCl you have to use. Okay. And phenol, add 0.5% of the phenol as a preservative. PP, both are matched. Phenol, preservative, both are matched. Like that you can remember here. Add glycerin also to increase the viscosity, that is 1.4 to 1.8%. Final volume consists of a 20 units per ml. Like that you have to prepare. Okay. Now store it in a cool place, solution in the cool place, and be cool. You are also be cool, and that is also kept in a cool place. Don't excite, don't get BP, don't tension. Happily you can use it, this standard preparation within a 6 months. Up to 6 months you can use. Once it crosses 6 months, again you have to make a standard dilutions again. Okay. Standard solution you have to prepare. Preparation of test sample also same process, no change in of it. Now dilutions, here you have prepared the standard solution, test solution, that you are going to be dilute. Now see, standard and sample dilution, these are freshly prepared by diluting with the normal saline, that is a NaCl, normal saline solution, so as to contain the 1 unit per ml, 2 units per ml. Like that you have to prepare a 2 standard, 2 tests. Totally you have a 4. Okay. Standard solutions 2, 1 unit per ml, 2 unit per ml. Now test solutions also 2. Like that you have to make a dilutions. Okay. Like this here, series of like a burette, 1 ml, 1 ml, like that you can calculate on the paper, and according to that you can be do it. Now we will see, that is a standard test solution. preparation, dilutions also over. Now you come to the rabbit method. In rabbit method, we are measuring the hypoglycemic effect of the insulin. Selection of the rabbits. Healthy rabbits you have, don't take diseased rabbits. Okay, healthy rabbits. So normal sugar will be there. If you are giving insulin, sugar value will be less. It will be lessened by the insulin. Weight is about 1.8 to 3 kgs, right? Okay, around 2.5 kg, like that average you can keep in your mind, average, okay? And diet is uniform diet you have to provide for all the rabbits. Uniform, it should be uniform. Fasting, before doing experiment, 18 hours of fasting must be there. That is compulsory. 1.5 day, that is 12 hours plus 6, that is 18 hours before the assay, you have to do a fasting. Not you, animals, fasting not by you, okay, before testing. Rabbits, you have to remove the diet, okay, 18 hours you have to, before the starting the thing, before the assay, okay. Water is withdrawn during the experiment. So whenever you are doing experiment, don't give the water to the rabbit. Don't give the water to the rabbit. Yeah, here the basic principle what I have to, again I am explaining, the potency of a test sample is estimated by comparing the hypoglycemic effect. That is very, very important. Hypoglycemic effect of the sample with that of the standard preparation, that we are going to be comparing, right? Here you can see this is the, generally we are using a for sugar, checking of a blood sugar level. This is how checking. This is the test. This is the international standard. These two we are measuring with the help of a thing. Yeah. And insulin injection, how you are giving to the rabbit? Subcutaneous route. Same in the humans also, they are taking a small needle injection. No? Subcutaneous route you have to give. Blood sample collection. See, whenever you are checking the blood sugar of a rabbit, take ear. Marginal vein of the ear that you have to catch. This is, see, this is the ear. In that margin, see the margin here. This is the margin, ear margin. In this ear margin, find the vein, which is in a blue color, dark blue color or green color. That you have to be catch it. From that, you take it 1 or 2 drops and keep on the strip, so that it automatically it reads what is the blood sugar level. Initially, you have to find out what is the presence of that is blood sugar. Estimated per 100 ml, 100 ml of blood, how much sugar is there, that you have to be calculate by using a suitable chemical method also you can use, or by using the mission also, reader. This is better. Okay, this concentration, initial concentration is known as the initial blood sugar level. Later you can give a, that is a insulin injection. And a sample is a blood you have to take. This is a blood sample, not urine method. This is a blood sample. Okay, and number of samples, 5 samples you have to take. Sampling, that is a interval is a 1 hour. So 5 hours you have to take. First hour, 0 hour, first hour, second hour, third hour, fourth hour, like that. Experimental procedure. When you come to the experimental procedure, there is a 2 parts is there, part 1 and part 2. Both parts you have to do. Both parts are mandatory. Animals are divided into 4 groups, 3 rabbits in each group. So 3 into 4, 1 dozen, 1, 2, that is a 12 rabbits you have to take. Okay, make into a 4 groups, 3 rabbits in each group. The rabbits then put into the animal holder, very well. That is a rabbit holder will be there. In that you have to hold it. They should be handled with care. So handle it slowly, rabbit. Don't do hangama and all. If you are doing a hangama and all, what happens? It undergoes the excitement. That excitement leads to blood sugar level will be further increased. So that avoid the, be cool, be calm, come lightly, handle very little. So now you come to the part 1. First part of the test, that is called as a parallel design. You have to compulsory, you have to do part 1 and part 2 also. I have told now 4 groups, group 1, group 2, group 3, group 4. 3 in each, 1, 2, 3, 3 in each group. So standard, I have told 2 preparations you have to make, 2 dilution. So standard sample, low concentration, first you have to give to the group 1, like that. At a time we can give 4 this test sample high concentration, test sample low concentration. Here standard, these are 2 are the standards, low concentration, high concentration. Test samples, low concentration, high concentration. Same day you can give. Okay, and you can from SC route you have to give insulin. Okay, and you have to check the marginal ear vein. Second part of the test. Here, this is called a twin crossover test or twin crossover test. Twin means you know very well. That's why here I made a twin. This one twin crossover. See how it is crossing, crossover design. Cross is there. Here, parallel design. All are parallel. That's why this is called a parallel design. Okay, this is a twin, two crossed over. See how it is. So here test sample with high concentration, you have to give a standard sample low concentration. Standard sample low concentration, you have to give to the group 4. That is test sample high concentration. Like that, you have to change this arrow marks. Twin crossover, that easily you can remember. Small cross, big cross. So two crossover, that's why it is called a twin crossover. Two crossovers are here. That point you have to keep in your mind. This is the same procedure what I have explained in the words, the same thing that is in the words. And yeah, finally you come to the conclusion part of the rabbit method only. Okay, concentration of the unknown is equal to threshold dose of the standard divided by how much concentration you got, that is divided into concentration. Just like a V1, V2, M1, M2 is there, no same method here. And the mouse method is there, that is a principle. I have already told you. Mice or mouse, whatever it may be, show a characteristic convulsions after subcutaneous injection of the insulin at elevated temperatures. Some body temperature elevated. In such a case, if you give a insulin, convulsions will come. Convulsions will come. But not to you. Convulsions will come to the rat or mice. The percentage convulsions produced by the test and percentage convulsions produced in the mouse by the standard preparation you are comparing. That is the basic principle you have to write in the examination. Experimental procedure, minimum 100 mouse. Oh my God, very big, too big. 100 mouse you have to handle. 100 mouse weighing about the 18 to 22 grams. Average is a 20. That point you have to keep in your mind. That's why here I am showing what we did in the lab. This is a mice weighing about, see here, 20 grams, 19.8 grams here. Are you observing? It's 20. Okay, but however, it's range from 18 to 22 because exact weight for all animals, it is not possible. Of the same strain you have to use. They should be maintained on a constant diet. Constant to all the diet. Okay, don't change the menu for same menu for all the mouse. Don't change the menu. They should fast it for 18 hours. Here also fasting. This is actually the real diet of the mouse. Prior to the experiment, 18 hours. So 100 mouse, 20 grams, 18 hours fasting. Okay, uniform diet. All you can easily remember with the help of a diagram. See here 100 mouse directly divided into 4 groups. 1, group 2, group 3, group 4. 25 mouse. Here it is not possible to show a 25. That's why I shown only 3. 25, 25, 25, 25. Here there is no crossover design. Keep in your only parallel design because you are taking number of animals. That's why one part is enough. Only parallel design you can be performed. Okay, so here also same standard solution low concentration, standard solution high concentration, test dilution low concentration, test dilution high concentration. Like that you can give it. Okay, dilutions are prepared with the sterile saline solution with the help of, don't take only NaCl solution so as to contain 0.064 unit. That is the standardly they have given 0.064, 0.096 units per ml. Okay, standard dilution. Similarly, test also you can prepare the same thing. Now, what you have to do, when you give an insulin injection, all the mice will undergo the convulsions. It shows like this. Whenever it is a convulsions, you have to note down. That point is very, very important. Mouses are put in an incubator because we have told you at elevated temperature. So all the mouse you have to put in an incubator at 33 degrees centigrade. You have to maintain. That it is nothing but elevated temperature. So insulin will start working and all the mice undergo the convulsions. And you have to observe only 1.5 hours. You have to observe. Within that only convulsions will come. Okay, and you have to take a glass front. and an air incubator. This is incubator. Inside I kept a mice here. This is a incubator. Glass front only you have to take. Glass front provided with a 6 shelves is like this used to use perforated plate. 6 shelves must be there. Each shelf bottom should be like this perforated plate. That point you have to keep in your mind. Okay, so that 33 degrees exactly you can be maintained, and it allows the visibility, glass window. If is there convulsions is there or not, that you can be find easily. The mice, either it is a die or it is under the convulsion, that you have to taken as a convulsions mice, convulsions rat only, like that you have to be consider. And if you have any doubt, there is one small technique is there. Either it is a convulsion or not, then you take the mice and put it in the on its back like this. On its back like this you have to put it, and observe either it is coming to normal position or not. If it is unable to come to the normal position on its own, then you can say it is a convulsion. If it comes, no problem, it is a not paralyzed, okay, not convulsions, like that. Okay, if it comes automatically, if it get reversed to a normal position, like that, what you have to do, you have to place the animal on its back, so automatically it has to come to the normally, not with your help. Okay, if it is unable to come, it is a paralyzed. So convulsions, if you want to remove the convulsions from the mice, if your test is over, some animals are still in the convulsions, you want to recover them, you want to help them, test is over, then what you have to do, if you want to recover them to the normal position, just give a 5% of a dextrose solution, because we know dextrose and insulin are opposite. To avoid the insulin effect, you give a dextrose, both are opposite, no, that we know very well, isn't it? So that insulin will be decreased in the rats or mice automatically. This is the formula. Percentage convulsions produced. Standard dilution to test dilution, test. Percentage convulsions, it means that out of 25 animals, how many animals undergone the convulsions? That is called a percentage. Okay, see it. 12 animals, if suppose undergone the convulsions in the 25 group, that 50%. Like that, you have to calculate. Okay, and according to that equation, you can be easily calculated the thing. Now, third method is there. Rat diaphragm method. In this method, only principle I will say, because not much important for even examinations also. Only write the principle part. Remaining procedure is same. Test standard 1, test 2, groups you are taking. Basic principle only I will tell. Remaining procedure is same as that of the both. So same you can be right in the examination. Rat diaphragm method. Here what happened in this method? Insulin increases the glucose uptake of the muscle. See, whenever you are doing exercise or whenever you are giving a insulin, your glucose which is present in the blood, it will be uptaken by the muscle. That point you can be remembered. So that blood glucose level will be decreased or muscle glucose will be increased. Muscle glycogen also increased. So you can take either any one. Muscle glycogen content increased. Glucose muscle concentration increased. Blood sugar level decreased. Rat epididymal fat pad method. See, name itself indicates fat pad method. In this method, what happened? The fat tissue, this is a fat tissue. It looks like a ring, just like a ring, because nucleus will be there apart. Easily you can be remember this diagram. Ring, your ring is nothing but a fat. You can keep in your nucleus will be at the side, at this one side only, not exactly at the center. That is a speciality of this thing. Okay, insulin, when you are giving insulin, this fat tissue increases the carbon dioxide production, that you are going to be measure. How much carbon dioxide is produced for the test, how much carbon dioxide is produced for that standard, both you are comparing, calculating, and finally. Radioimmunoassay method. This is also comes under bioassay only. Okay. Here, principle is depends upon the ability of the human insulin, either a test insulin or standard insulin, displaces the beef's insulin. That is a key word you have to keep in your mind. That I will show you in the diagram in the stepwise, but keep in your mind displacement of the beef insulin by the human insulin. That is a standard insulin or test insulin. How much amount is displaced? That is going, you are going to be calculated. Bovine is nothing but a beef. That point you have to give. Sheep is different. I will show you what is a sheep, what is a beef. That and all I will show you. Okay, so estimated the concentration of the substance with using a radio labeled antigen. It is a highly specific, highly sensitive. Is a valid method. This method. Yeah, here I show you. See what happened. First, this is very simple diagram. This diagram is very, very important here. What you have to do is, first you see this is a beef. This is the sheep. Sheep. Beef is also called as a bovine. From this we are taking a insulin. We have already in our lab standard preparation, test preparation, we have already. Okay, that you keep aside. You take a beef, take the pancreas, take the insulin of the beef. Okay, so beef insulin is there. That is nothing but bovine insulin is there. This bovine insulin acts as an antigen. You have to make it radio labeled. That insulin, after extracting it, you make it radio labeled. You add some labeling, just like a radio labeling you have to do, and inject into the sheep. This is a black sheep. This is a black. How many wool? SR, 3 bags full. This black sheep you have to inject. This insulin we are injecting to the sheep. Okay, right? Now what happened? It will be treated as a antigen. The sheep will be treat the insulin of this bovine insulin as a, and it started producing the antibody. So first antibody it will be produced here. Okay. Now you see this is a radio labeled antigen. It is nothing but a bovine insulin. This is an antigen. Okay, from this. Okay, and you are injecting to the sheep. Okay, so what happened? This prepares the antibodies. These are called an antibody. This Y color is called as an antibody. Now this is a complex antigen antibody complex. This antibody is from the sheep. Antigen is from the insulin beef. Okay. Now what happened? Our test preparation. See, take the test preparation now. Example is 0.1 ml or 0.2 ml, whatever it may be. Take the insulin preparation now. This is this is unlabeled antigen. Keep in your mind. We are not going to label this antigen, but this label we are antigen. We are labeling here. This insulin, when you give this insulin in vitro, this you have separated now from the sheep. You have extracted from the sheep. Antigen antibody complex you have separated, and it was there in the beaker. In your beaker is there. To that, what you have to do, insulin test preparation you have to do. So when you will give now, what happens? See, this blue color is nothing but a human test insulin. It replaces the radioactive antigen. See here, it becomes a free. So how much it is displaced? Okay, bovine insulin or beef insulin is displaced by the human insulin. How much it is? That is directly proportional to the percentage. Okay, so how that you have to calculate here. Now what you have to do, precipitate the antigen antibody complex, and you have to go for secondary antibody will come. Okay, that's not much important, but how much radioactive supernatant, that is if you go for centrifugation, supernatant free antigens will come on the top. That you have to detect the radioactivity. From this, what you have to do, amount of the free labeled beef insulin which is displaced by the insulin test preparation gives the concentration of the test insulin. This point you have to write. Very, very, very important. Once you got this test preparation, now what you have to do, you go for the standard preparation, same procedure. So here also you will get one value, amount of the free labeled beef insulin which is displaced by the insulin standard preparation. Both you have to calculate by using same above formula. What I have given, same one. How much you have given, how much radioactive label become, compare the doses, compare the two values. Easy. This is the procedure. Same what I have explained in the words. The same thing only you have to. Okay, so I end here. So in playlist, I have kept all my videos that you can be watch it.